Welcome to Open Source Video Game Part 3, and again, special thanks to all my subscribers. We have a lot more to cover, so let's get started right away. Part 2 discusses variables in some but not all command words. You may be wondering about the rest of Python's command words. I will continue to go over the rest of Python command words by the way they operate, because very few Python command words apply by its own self, like we saw the from, as, and asterisk displayed in Part 2. Rather, most but not all Python command words are triggers that set or take place in events, like we saw with the from command. For example, when the from command is used, Python expects the import command word to be used in tandem. This is why Python refers commands as statements, operations, or expressions, like our next topic. Comparison operations is simply the logic of our video games. Video games are very interactive, and as a video game developer, we need a way to constantly check situations within our game, a game controller, a mouse, a keyboard, or any other device. Comparisons are the what if and allows the developer to develop a game that may respond to any situation that may or may not occur. Comparisons yield Boolean values, true or false. The operators strictly less than, strictly greater than, equal, greater than or equal, less than or equal, and not equal all compare the values of two Python objects. The exclamation mark equal can also be written as less than and greater than, but this is an obsolete usage kept for backward compatibility only. New code should always use the exclamation mark equal. Note, we cannot use the single equal sign because Python reserves a single equal sign to bond a value to an identifier, as displayed in Part 2. Objects do not have to be the same type. If both are numbers, they are converted to a common type. Otherwise, objects of different types always compare unequal and are ordered consistently but arbitrarily. I should mention you may control comparison behavior of objects of non-built-in types, yet we will not need for our current project. When applying a comparison operator, Python works 4 steps. Evaluate both argument values, convert both parameters to the same type. Numbers are converted to progressively longer types, plain integer to long integer, to float to complex. Do the comparison and return true or false. I point out these 4 steps explicitly because there are some subtleties in comparisons among unlike types of data. We may come to this later after we cover sequences, mappings, and classes. Generally, it doesn't make sense to compare unlike types of data. After all, you cannot ask which is larger, the Empire State Building or the color green. We even have the option to compare a chain of conditions. The AND operator results true if both operands are true, or the OR operator results true if any one of the operands are non-zero or non-false. The NOT operator is used to reverse the logical state of its operand. If a condition is true, then the logical NOT operator will make it false. Comparisons can also be combined in Python, unlike most but not all other programming languages. We can ask 3 less than or equal to variable a less than 3.2, which has the usual mathematical meaning. We're not forced to use a longer form, 3 less than or equal to variable a and a less than 3.2. This is useful when variable a is actually some complex expression that we'd rather not repeat. Also note that this example has a mixture of an integer and a floating point number. The integer were coerced to a floating point in order to evaluate the expression. Exact comparisons between floating point numbers is a dangerous concept. After a lengthy computation, round-off errors in floating point numbers may have very small differences, as discussed in Part 1. The answers are close enough to equal for all practical purposes, but every single one of the 64 bits may not be identical for comparison. For an appropriate way to do floating point comparisons, I would need to show you another Python built-in function called ABS. This function will return the absolute value of a number. The ABS argument in this case may be an integer, long integer, or floating point number. If the argument is a complex number, its magnitude is returned. We see more of Python's options for shorthand practice in the first line. It is possible to bind as many variables to an equal amount of values or other identities separated by commas on both sides of the equal sign. We may also do math equations in place of the values, and Python will bind the result of the equation to the variable we are assigning it to. The / operation in Python is simple division. The second line is the built-in Python print function we saw in part 2. To display variable a, b, and the Boolean result of a is equal to b. You may be wondering, what purpose does the Boolean true and false actually do? You may think of Booleans as either a fork in the road or even a better example like a railroad switch. Python is indenting sensitive. Anything indented, Python identifies as a block of code. Thus, the indentions must stay consistent. This feature of Python is my favorite because it really makes our code very easy to read and assists us to maintain good practice. Blocks of code is what a developer wishes or not wish to be read by Python as the program is executed. By indenting our code, it is clear to Python and readers the code within the block is reserved for a condition or other identity. Staying focused on the condition perspective, the block of code will only be executed by Python if the result of the condition in the heading is true, and Python will bypass the entire block of code if the heading condition happens to be false. You may even indent as many blocks of code as deep as you wish. To let Python know your condition or other identity heading is complete, we must follow it with a colon, which Python will expect an indentation on the next following line. Any amount of spaces can be used to indent as long as it is consistent. To help consistency, the tab key is normally used, and Blender gives you the option to customize how many spaces you wish to indent while using the tab key. 4 spaces are considered the standard. The if statement works exactly how it sounds. We simply ask Python if true or false, and Python will answer us as a Boolean object, which determines whether the preceding block of code will be executed or not. This means anything that will return a true or false may be used with the if statement. If any variable is identified to any kind of value with the exception of the none value, the variable is considered true, otherwise it is false. If we have variable a identified to a string and variable b identified to none, we may state if a, Python executes the indented block below it. Although, when we ask if b, Python does not see any value identified to it, thus Python returns a false and does not execute the next line. None is used because if we were to attempt to call upon variable b without any assignment, we will get an error. None allows us to have a variable and not making us hold any kind of value type. If the suit of an if clause consists only of a single line, it may go on the same line as the header statement. We may even negate the false to actually return true with not. As before, the a variable is still a string and the b variable is still none. Yet if we ask if not, we are really asking Python if the condition is false, which it is, so Python returns true and now executes the next block of code. You may think of the if not as by asking Python if the condition is false instead of asking if true. If the condition is in fact false, Python will respond that it is true that the condition is false. The elif statement is short for else if. The elif is commonly used when checking multiple conditions to assist optimization. The difference between the if and the elif statements are multiple ifs means your code will go and check the entire conditions, whereas in case of the elif, if one of the conditions satisfies, it will not check the other conditions. The else statement is used when all previous conditions fail to execute, and in that case you wish to execute a final conditional else block of code. When checking multiple conditions, a basic format may be used, starting with the single if, following any number of else if, and ending with the else statement. The first if statement starts with the basic condition check followed by a number of elif that will execute if just one returns as true, ending with the else that will execute its block of code if all the above had failed to execute. The else statement may follow an if or elif statement. Modern computers can do millions or even billions of executions per second. With the techniques discussed thus far, it would be hard to get a program that would run by itself more than a fraction of a second, and that wouldn't amount much for a popular video game. Particularly, we cannot write millions of instructions to keep the computer and game players busy. To keep a computer doing useful work, we need repetition, looping back over the same block of code again and again for all the sorts of reasons. There are two Python statement types to assist: the data type loops, which we'll take up shortly, and the while loop, which we'll take up later. The order of execution will always be the order of the lines in the table, in this simple sequential code that also follows the textual order of the program, following each line of execution of a program in order, carefully keeping track of the current values of the variables. This is a concept called playing computer. A table like the one here is an organized way to keep track. This is a for loop. It has a heading starting with for followed by a newly created variable name known as the iterating variable, count in this case, the word in, some kind of sequence, and a final colon. As with the if, elif, and else statements and other heading lines, the colon at the end of the line indicates that a consistently indented block of statement follows to complete for the loop. The for command word tells Python we're about to enter a loop data sequence block. Python will extract each value of the sequential data type we place after the in statement and bind it to a temporary identifier name we placed before the in statement. In this case, the temporary identifier name is count, which will identify the integer value of 1 on the first pass because Python had extracted the integer number 1 as the first item of the list. Python will proceed to execute the block of code following the for heading. Notice we can use the count identifier name within the block and it identifies our first item of our list, which is, in this case, count identifying the integer number of 1 on the first pass through the loop. When Python finishes the first path, Python will identify count to the next item within the list, in this case the integer number 2, and proceed to execute the block again. Next, the last item within the list will be identified as count, and Python's last pass through the preceding block of code. We will get the same result if we identify the list to a variable called numberList. As with the if statement header, if we have a one-line body, we have the option to follow the header with our single line of code after the colon. Although this may cause your text lines to become too long and run off the margins, this could result in a script that is harder to read. Whatever method you use, keep it consistent so that it is easy to read by others as well as yourself if you were to revisit your own code at a later time. Another way to sequence an identifier is to simply mathematically add to its value with the help of a data loop sequencer. First, we identify an integer number of 1 to the name of number. Identify color list to a list of strings to store the colors. Use the for statement to set our sequence loop through the items in color list. Print the value of number and color. Then use a shorthand method to increment the value of number by 1. This shorthand method is the same as number equals number plus 1. This shorthand can be used with other mathematics as well, such as number minus equals 1, number divided by equals 1, number times equals 1, and more. Part 4 will explain more about mathematics. The else statement may also be used with the for statement. Python will execute the else statement after the for header and block has been exhausted. The while statement may be thought of as a looping if statement. While a condition is true, the preceding block of code will continue to repeat unless instructed to break out. First, we identify a number to the integer number of 1 and the identifier time to an empty string. We use the while statement following a condition, number less than or equal to 10. Python will execute the preceding block of code repeatedly as long as the condition remains true. We added an if statement to assist our output's proper grammar. Notice that this creates a block within a block. In fact, we can have as many blocks deep as we wish. If the value of the number is greater than 1, then we identify time to a string times, else the identifier time will be the string time. We print an output of a string looped. It is also possible to break out of the while loop with Python's break command word. Here we have the same output as we did in the previous module, but just wrote differently to show an example of how the break command word works. I must tell you a word of caution. When using a Boolean value true in place of the while condition, doing this will create a never-ending loop and may cause Blender to crash because the condition is always obviously true. If this ever happens, just restart Blender and always remember to save your work often. When using true as a while condition, there is no other way out of the endless loop unless we use a command break. The break command word simply halts Python from executing any further within the current block of code and jumps to the next following line of code after the block. Python's continue command word halts Python from continuing on with the rest of the block of code and starts the current block of code over again from the line preceding the while statement header line. That is all the time we have for part 3. In part 3 we learned about commands as statements, operations, or expressions. Comparisons such as strictly less than, strictly greater than, equal, greater than or equal, less than or equal, and not equal. The steps that Python does when the comparison statement is used: evaluate both argument values, convert both parameters to the same type. Numbers are converted to progressively longer types, plain integer to long integer to float to complex. Do the comparison, return true or false. Different ways to compare a chain of conditions with the and or statement, as well as the combined and condition chain. We learn how to negate the conditions by using the not statement. How to properly compare floating point numbers with Python's built-in absolute value function, what a Boolean value does, and indenting blocks of code. How to include logic into our code with the if else, and else statements. Loops and sequence data such as the for and while statements. Different ways we can use the else statements such as the if, for, and while statements. How to use the break and continue statement with the while statement. We also learned how to prevent our code from never-ending loops. Part 4 We'll start with mathematics, functions, and classes.